there. I wanted to start with pick up with the trigonometry review, but one of my sections needed to do the parallel and perpendicular lines. So if you want to speed through this part, you can. As far as parallel and perpendicular lines, what we're looking at is for parallel lines. Oops, wrong thing. For parallel lines, we have two slopes that are equal. M1 equals M2, so my two slopes are equal. And for perpendicular lines, M1 is equal to the negative reciprocal, so we flip it, negative 1 over M2. All right, so let's take a look at whether the pair of lines are parallel, perpendicular, or neither. What I'm going to do is I'm going to get these into this slope-intercept form so I can find M. The B part is not going to matter that much, but we'll move that over too. So for the first one here, what I'm going to do is, let's see, I'm going to move the 15x and the 4 to the other side, so I'm going to subtract both of those. I'm going to get a negative 5y, let's zoom a bit, there we go, is equal to negative 15x minus 4. And now I'm going to divide everything by a negative 5. So all this is divided by negative 5. That means each term there on the right-hand side is divided by negative 5. So I get a y is equal to a 3x plus a 4/5, right? That means here, if I'm looking at this, since this is in y equals mx plus b form, m1 is equal to 3. Let's take a look at the second one. Again, I'm going to move everything to the other side. I'm going to get a 3y. Sorry, not everything. I'm moving the x and the negative 9, the minus 9 to the other side. So I'm subtracting the x, so I get a negative x. I'm adding the 9 to both sides, so plus a 9. Now I'm going to divide everything by a 3. So you can do individual numbers if you'd prefer, like this. Let's see, and then I'm going to have a y is equal to negative 1/3 x plus a 3. Again, I'm really just interested in that slope. So M2 here is equal to negative 1/3. And what you can see is that if I look at this 3 and the negative 1/3, they're negative reciprocals of each other. And so that means these are perpendicular lines. It's a funny looking R. All right. If let's say M2 is equal to just negative 3, they would be neither, or if it was equal to 5 or anything besides either 3, if M2 and M1 were both equal to 3, then we would have parallel lines. In this case, we had perpendicular. Anything else would be neither. All right. Trigonometry review. So we want to find the angle of least positive measure and the negative angle that is closest to the coterminal to the angle of 402 degrees. Remember, coterminal angles are 360 degrees apart. Okay, so what I'm thinking is doing a plus or a minus of 360 degrees. So let's start with our first one. The first one we're going to get 402 degrees minus 360 degrees. And what you should get is a 42 degrees. This is my smallest positive angle that I get. So this is my angle of least positive measure. If I want to keep going and finding the negative angle, my first negative angle, I'm going to take that 42 degrees. And I'm going to subtract off another 360 degrees. And what I should get is a 318 degrees. Right? Very neat, right? So those are my two coterminal angles that I've come up with. Oh, and it's negative. Let's make it negative. There we go. That looks a lot better. Don't forget the negative sign with the 318. All right. Assume theta is in standard position, whose terminal side contains the point 2, negative 6. So where we're at is, let's imagine, I'm going to go over 2 in this positive direction. 1, 2, and down 6. 1, 2, 3, 4, 5, and 6. So we're down here. So this is a negative 6, and this is a positive 2. This is my x, my y. There we go. So if I plot that point, I'm right about here. Draw a line. Okay, this is the terminal side of my angle. That means that my angle looks like this, right? But what I know is that if I'm looking at the values for, sorry about that, for those 6 trig functions, I could also use this triangle and this angle here, because this is my reference angle, right? So it's kind of my theta 2. What I know is that this point down here is at 2, -6. That means I went over and that this distance right here is up here is 2, and that this distance right here is 6, actually -6 because I went down. And so what I'm going to do is I'm going to use that information. Let's draw this triangle a little bit outside. If you were in the class that did this problem, this might be a little bit easier to see. So the 6 trig functions of this angle theta are going to be the same as the ones that we had with the other one. If I want to get the length of the side right here, what I'm going to do is I'm going to say, let's call it h, since it's a hypotenuse. That's equal to the square root of 2 squared plus my -6 squared. And that's equal to the square root of 4 plus a 36. And so I get the square root of 40. If I bring that over, let's see, I could simplify that radical. 4 times 10. And then I can get this 4 outside of the square root. So I'm going to get a 2 square root of 10. Okay, so 2 square root of 10 is what my hypotenuse is. Now what we're going to do is use SOHCAHTOA to start with. All right, so that means that sine of my theta is going to be equal to my opposite over my hypotenuse. That means it's equal to 2 over a 2 square root of 10. Don't leave it like that, okay? That's not my opposite. Hold on, let's back up. Oh, no, let's back up. All right, let's read the right side. My opposite side is the side that's opposite the angle, so it's equal to a -6 over 2 square root of 10. That makes more sense. I was looking at it going, what's wrong? All right, so that's going to be, if I reduce that, this becomes a 3 and this becomes a 1. And so I'm going to get a -3 over root 10. That's my sine value. My cosine function is equal to adjacent over hypotenuse. That means I want this side. That's my adjacent side right there. So now I get to do 2 over 2 square root of 10. And that's going to be equal to just a 1 over the square root of 10. If you want to rationalize these, you can. It really doesn't bother me. All right. Last one, tangent theta on this part is equal to opposite over adjacent. So my opposite side was -6. My adjacent was 2, and so I'm going to get a -3 off of that one. All right. Now it asked for the 6 trig functions, so let's find the counterparts or the friends of these. Remember, with sine, we have cosecant theta. That's equal to 1 over sine theta. And so I'm going to use this, and I'm just going to flip it. It's going to be equal to, let me move this over just a little bit for us. I think I got it all. There we go. 1 over sine theta. So I'm just going to flip this. I'm going to have a -√10 over 3. Same thing here. Cosine and secant go together. Secant theta is 1 over cosine theta. And that's going to be just a square root of 10 when I flip that fraction over here. So I'm coming from here and I'm flipping it. And then cotangent of theta is equal to 1 over tangent theta. Again, I'm going to flip it. I'm going to get a -1/3. There we are. All right. Well, hopefully that makes sense as far as how we get those 6 angles there from that triangle. All right. And we don't have to, since I put the negative there on the length of that side, I didn't have to do anything with the signs of these. Speaking of signs of functions, if you look, we have 4 quadrants, right, in our unit circle. So in quadrant 1, Here in between 0 and 90 degrees, all trig functions are positive. So we have an all, which is an A. Everything's positive. In quadrant 2, over here, if you look through the list there, the only ones that are positive are the sine and the secant are positive. So we can say all students. It's a nice memory trick. Oh, that's not a students. There we go. Again, quadrant 2, between 90 and 180 degrees. If I go to quadrant 3, you can see that the only thing that's positive are tangent and cotangent. We use the take here for T for tangent, because the tangent and cotangent are positive. And then in quadrant 4, over here between 270 and 360 degrees, what I see is cosine and secant are positive. We say calculus. So if you remember that all students take calculus, then you know what's positive in that quadrant, and then you can figure out what the sign is of your trig function. All right. So let's take a look at an application of that. Determine the signs of the trig functions here. So we have secant of 228 degrees. That's equal to 1 over cosine of 228. All right. So cosine of 228 degrees is in quadrant 3. And as I think of all students take calculus, right? What I know is that for cosine, I'm positive in the first quadrant, and I'm also positive in the fourth quadrant. That means I'm negative in these ones. And so this is less than 0, or if you want to say negative. Let me move this up just a tad so I have room for the second one. The next one here, the tangent or cotangent of 163 degrees. That's the same as a 1 over tangent, if you want to think about it that way, of 163 degrees. If I'm looking at the 163 degrees, we'll go up this way. That's going to be in quadrant 2. Again, coming over here for tangent. All students take, it's positive in the third quadrant, calculus. So it's negative in these two quadrants. And that means, again, this is less than 0. So this, again, is negative. Right, we are almost there. All right, the last two problems. Let's see. So we have determine the quadrant in which the terminal side of theta lies, subject to both the given conditions. So here for the cosecant, what I know is cosecant is equal to 1 over sine of theta, and it's greater than 0. So I want a positive sign. So let's look at sine. So for sine theta, we get all students take calculus. So down here in the bottom half, makes sense, it's the y value. It's negative. So I'm looking at either Q1 or Q2. If I take a look at my tangent theta is less than 0, right? So let's look at the tangent sine graph or sine chart. All, so there, students take, down here we're positive for tangent calculus, so we're negative here and here. So I'm negative, which is what I want, in Q2 or Q4. So when I look at what's in common here, I notice that both of them have Q2, so I'm going to say this must be in quadrant 2 for both these things to be true. All right. Not too bad. I really encourage you to make the quadrant graph. It really, really helps. It helps you think, and then you can write down the 2 where it works. Last example for this. For the given value, determine the quadrants in which the terminal quadrants in which the terminal side of the angle lies. So here I have tangent theta is equal to 4.400. That's greater than 0, right? And that's really what I'm looking at here. So let's look at that tangent graph again. It's right up above. But again, all students, so now it's negative in the second quadrant, take, yes, tangent's positive in third quadrant, calculus, negative there. All right, so if I want it to be positive, the terminal side must be in Q1 or Q3, right? And that's all I'm looking at there. So that's where my terminal side has to be. I hope that's helpful. It's kind of trig in a nutshell, and we'll work on vectors next week. So if you have any questions, let me know. And this is the last of the review packs. Thanks. Have a great day.